In this video, we're going to look at the area of 2D shapes. The area is simply the space trapped inside the shape. Let's start with a couple of shapes that we've met before. We're going to have a square and a rectangle. So here's a square and then we'll have a rectangle. With a square, we have all of the side lengths the same. So we can denote that now by showing that all of these side lengths are going to be the same. If we want to find the area of the square or the space trapped inside, we can say A, the area, is the length multiplied by the width. So with a square, each of these side lengths will be the same. So if we were told now that this was 4 centimetres, we could say that the area is going to be 4 multiplied by 4, or if you like, 4 squared, and that's going to give me 16. The units I'm going to use are centimetres squared. If we have an area, whatever units we're using, we will have centimetres squared, millimetres squared, or whatever the unit squared is. If you want a way of thinking about this, what I'm going to do is draw a line. A line is one-dimensional, and we could write now that if we were working, for example, in metres, this would just be metres. We don't see the little one here. If we have now an area, the area would be metres squared. So this is a two-dimensional shape. So to remember it, we can say it's going to be metres squared. So one-dimensional, two-dimensional. If we have a volume, let's go ahead and do a volume. So what I'm going to do is grab up now. So let's put this triangle on, and I'll just go ahead and make this into a 3D shape. So if we have something that looks like that, let's do that. Then we could say now that the volume of that shape is going to be in metres cubed. So if we were measuring each of these in metres, this would be metres cubed. One-dimensional, two-dimensional, three-dimensional. 1, 2 and 3. Of course we don't write that little 1 normally. So that's now some units for you to use. Let's now look at the rectangle. If we have a rectangle, let's say that this is going to be 9 millimetres and this is going to be 3 millimetres. All we would do to find the area is do 9 multiplied by 3. It doesn't matter which way round you do it. 9 multiplied by 3 is the same as 3 multiplied by 9. So 27, and the units will be millimetres squared. So nice and straightforward, that gives us the area of a square or a rectangle. Remember, a square is a rectangle. It's just a special case. Let's now move on and look at the area of a parallelogram and a rhombus. So just drawing these up, this is going to be my rhombus, and then we'll have a parallelogram as well. With the rhombus, this is essentially a bent square. So all of these side lengths are equal. We've got the parallel lines just here, and we've got the parallel lines just here. They are all of the same length. With the parallelogram, we have 2 sets of parallel sides. If we want to find now the area of a parallelogram or a rhombus, we simply need now the length right here and the perpendicular height. So let's take the parallelogram. Let's say that this is going to be 5, and we'll say that this is going to be 5 metres long. What I need to find the area is a perpendicular height. So 90-degree right angle here, and we can put that height on. So if we were told now that that was going to be 3 metres, let's just put that on. Let's say that's going to be 3 metres. We can say that the area is going to be equal to 5 multiplied by 3, and that's going to give us 15 metres squared. We must have the perpendicular height, not the slant height, to work with. We could of course try and find the perpendicular height from the slant height, but that's a bit beyond the scope of this particular video. So that's what I've got. Now you're probably thinking, well, that's the same formula as what I've just done here. If you want to think about this now, if I drew some lines on here, and I'll just make this slightly bigger. If I take a parallelogram, we can actually make it into a rectangle. So what I'm going to do is cut off now one triangle from here. So I'm going to take the triangle from there, and I'm going to place it just there. So from that now we can see that if I took this triangle off here and put it over here, we have a rectangle. We can see now, we know that these two lengths are equal, so this would become 5 metres, this would become 3 metres, and we would simply be finding the area of this rectangle. So that's why it works. It's nice and straightforward. So areas of rectangles, squares and parallelograms are simply the base times by the perpendicular height. Okay, let's go ahead and look now at a triangle. So if I take a triangle, and what I'm going to do is start with a rectangle. So if I think about this now, and I'll put some dimensions on this, I'm going to put on here that the rectangle is going to be, and we'll say that this is going to be, we'll have 8 centimetres, and we'll say that this one is going to be 3 centimetres. So not massively accurate. So if we think about the area of a rectangle, it would be 8 multiplied by 3, and that would give us 24, and the units are centimetres squared. If I think now of a triangle is half of a rectangle. So we could go ahead and cut this. So if I cut this down here, what I've got now is the following, and I'm just going to put the dimensions on here. I've got here a triangle. So triangle, that's going to be 3 centimetres. And if I just had this part right here, we could work out the area. Now from this, it's fairly logical to see that this is just going to be half a rectangle. So I could say that the area of the triangle, so I'll just write that as T, is going to be 12 centimetres squared. All we're doing is the base, which is 8, multiplied by the perpendicular height, which is 3, and we halve our answer. It's half of a rectangle. Students often forget that and write in the exam that if we have a 3 by 8, it's 24. We can see clearly that 12 of it is in here, so let's put 12 in here. So 12 is in here, and the other 12 is in here. So that is the area of a triangle. All we need is a base and a perpendicular height. So if we look at another example, let's go for this one right here. Let's say we've got on here a base. So we've got our base just here, and then we have a perpendicular height. So perpendicular height is the straight up height, and we'll say now that this is going to be, and we'll put this on. Let's say that this is going to be 9, we'll say that's 9 centimetres, and we'll say that the base is going to be now 8 centimetres. All we would do to find the area is do 8 multiplied by 9 and divide it by 2. You can work it out first. You can do 8 times by 9, which is 72, divided by 2, and that would give us now 36, and it would be centimetres squared. So base times by the height and half your answer. So with all of these, triangles will come in different. Let's do some different types of triangles. We might get something like this. So this one might not be as obvious. But as soon as we get a perpendicular height and a base, we can work it out from there. So if I do that, let's say we've got now this one, and this is going to be 5.4 millimeters, and this one is going to be 4.27 millimeters. All we would do is 5.4 multiplied by the 4.27. In a calculator, we can find that answer. So 5.4 multiplied by 4.27, and that's going to give me in total 23.058. So I'm going to say 23.1. So 23.1 millimeters squared, and that's correct to 1 decimal place. So nice and straightforward. So it doesn't matter what your triangle looks like, as long as you have a perpendicular height, a straight up height. We couldn't do it now with the slant height here, just this part right here. And we'd have to use advanced techniques if it wasn't as straightforward as we've got. And there is a video on that. Okay, let's move on from the triangle and look at the kite. The kite, the reason I'm branching these off is that we can see these all pretty much as one. And we can also see the kite is the same as now the triangle. So if I draw up a kite, let's grab a kite. That's what a kite looks like. So what we're going to have with a kite is the height. So let's put the kite height. There we go. And we're going to have a width. So if we have these two, all we do is exactly the same as a triangle. We do this height multiplied now by the width, which is this part right here, and then we divide by 2. So let's say that we've got now, and we'll put this on, so this is H and this is W. We do that the area is going to be H multiplied by W, and we halve our answer. So let's say that this is going to be 2 meters and this is going to be, let's say, 9 meters. I would say that the area is going to be 9 multiplied by 2, and then we halve our answer, and that's going to give me 9 square meters. So 9 square meters, or 9 meters squared. So nice and logical, nice and straightforward. If you're again unsure of why this is the case, let's just go ahead and look at one way that we could do this. If I now put a line down here, a perpendicular, and I moved this triangle to just here and dropped it down, so that one's just there. Let's just make that look a bit neater. So that's that one. All I've done is pick this triangle up and put it here. If I do exactly the same down here, what we end up with, and I'm just going to draw that on like so, that one will come across and then we can go across here. So all I've done here is simply taken this part, so I've taken this part here and I've placed it just there. I've taken this part just here and placed it just there. What we can now see is that we have a rectangle with the same height but just half of the width, or if you like, half the length. So this would be 1 meter instead of 2 meters. So nice and logical, nice and straightforward. What we will do while we're here is just make this slightly tougher. Let's do quite a nice question. So this is what I'm going to have. This is a kite, and I'm going to be given now the following. Let's make this a bit more challenging. So I'm going to be told now that, and what we want to do is the following. We're going to find, and I'll place this somewhere different. Right, so we're told that this is going to be the height. Let's put that on. And I'm going to say that this here, let's put here, we can say that this is going to be 8 meters. I'm going to say now that the area is going to be equal to, let's say, 24 meters squared. And what we want to do is find the height. So this is not drawn accurately. So if we look at this, we can say that the area is the height times by the width divided by 2. So 24 is going to be 8 times by h, or we could say now 8h, and then we divide by 2. So 24 is going to be equal to 4h. Dividing both sides now by the 4, we can see that h would be equal to 6. So we can work this backwards. In the same way, if we had a rectangle, if we were told that the area of this, let's say this one right here, was going to be, we'll go for 42, and we'll say meters squared, and we were told that this length was x and this length was, let's go for, we'll take 3, then what we could say is the length times by the width, which is going to give 3 times by x, which is 3x, is going to be equal to 42. So x is going to be 42 divided by 3, which is going to give us 14. So that would be now 14 meters. Another way of looking at what do you need to divide 42, or 42 divided by 3 is what? So sometimes you're just going to be working these backwards. Okay, so that's a kite. So we've looked at a square, a rectangle, parallelogram, rhombus. We've looked at a triangle, we've looked at a kite, and now we're going to look at a trapezium. Circles are covered in their own video. So let's first look at a trapezium. It's massively important to say that this area is actually in the formula book. So what we've got with a trapezium, or a British trapezium anyway, is that we have these 2 parallel sides. So if we have this one, we'll call this A, and we'll call this one B. And then we have a perpendicular height, which we'll call H. To find now the area, let's just put this on. To find the area of this, let's put H on. We say that the area A is going to be A plus B, and then what we're going to have is divided by 2 multiplied by H. So often it's a case of just going to the formula book if you forget this one. Top plus the bottom divided by 2 and then multiply the height. So let's draw one up and have a go at it. So let's just put on one of these. So let's put some lengths on here. So what we're going to have, I'm going to have a perpendicular height. So let's put a perpendicular height on here, and then we'll put a value of A and B. Remember, we're looking for the 2 parallel sides. So let's say now that this is going to be 4 millimeters. This is going to be 3 millimeters, and this one right here is going to be, let's say, 5 millimeters. So my area is going to be the top plus the bottom, so 3 plus 5, which we need to divide by 2, and then we're going to multiply by the height. The height is 4. So this gives me now that the area is going to be 3 plus 5 is going to give me 8. 8 over 2 is 4, so we get 4 times by 4, which is going to be 16 millimeters squared. So nice and straightforward, nice and logical. Why does this work? Well, let's have a logical think about this. If I now draw a line from the corner to the corner, what I've got here is one triangle, and if we look at the area of this one right here, the area of this triangle with a base now of B and a height of H, the area is going to be 1/2 multiplied by the base times height, which is BH. If I look at this one, what we've got is a base of A, and it might be easy if you turn this upside down, so the area of this one is going to be 1/2 A multiplied by H, so times AH. So if we add these together, this is what we're going to end up with, and it's just a different way of seeing it. So you've got two triangles, you've got this one right here, that one right there, they're added together, and it will give us this formula here. So you can see the area of this one is 1/2 AH, this one is going to be 1/2 BH, and all it does is factorises to give this particular formula. Hopefully that's made some sense. You're not going to be asked to prove it or anything, but I think it's important to put it in there anyway. Remember, not all trapezia are going to look like this. So we might have, for example, let's draw a different type. Let's say we've got something that looks like this. So this is a trapezium as well. Once I make that, let's just make this work. So now if we put that like so, and we've got a right angle just here, so let's look at this one here. We'll put our right angle just here. So we can see now that the parallel sides, these are the parallel sides, the top and the bottom. So this one with this one. So if we had now perpendicular height, which is denoted by the right angle, let's say that this is going to be now 4 millimeters. And let's say that this one is going to be 8 millimeters. And this one right here is going to be 16 millimeters. We can simply say that the area is going to be the top plus the bottom. So 8 plus the 16, we're going to divide that by 2 and then multiply it by the height of 4. So what's that going to give me in here? That's 24. 24 divided by 2 is 12. So we end up with 12 here, 12 times by 4, and that's going to give me 48, and my units are millimeters squared. So logical, straightforward, that is another trapezium. Two parallel sides right here, perpendicular height, so we can find the area. So there we go, area of 2D shapes. We've got squares, rectangles, parallelograms, the rhombus, we've got triangles, we've got kites, and finally we've got the trapezium. If you do really struggle to work out using this particular formula, one thing that you could do, especially with this last one, is just split it up. So if I think about that now, I could drop another perpendicular, and remember, you might see that we have another right angle here on the shape, just to show that they're perpendicular. If I look what I've got here, and we'll just do this, let's do it a slightly different way. If I now cross out the 16, what I've got here is 8 here, up until this point, as we've got a rectangle, and then we're left with 8 millimeters just here. It's not always going to be the same value, it's just worked out that way. So this one is the area of a rectangle, so that's going to be 8 times by 4, and this one is going to be the area of a triangle, which is going to be 1/2 of 8 times by 4. So 8 times by 4 is going to give me 32. 8 times by 4, 32, 1/2 of that, 16, and we can see that those add to give 48. So another way of doing it, splitting it up like so, but if you can use the formula, it's often a lot more straightforward.